Hello, YouTube learners, students, and friends. This is Dr. Satish Singhal, PhD, Professor of Computer Science from El Camino College, Torrance, California. Today I want to talk about hexadecimal numbers, what they are, procedure to convert hexadecimal numbers to decimal numbers, its algorithm in C language, and then source code in C language. So there will be 4 videos. Hopefully they'll be short. This is the video number 1. So basically, there is a numbering system called binary, which has only 2 digits, 0 and 1. And I might do other video on them, but if you're curious about them, learn their description from Wikipedia. Go to Wikipedia, just type binary system, and you will get something. The binary numbers are excellent in representing small numbers, like 10, 20, 100, something like that. The problem comes when one has to store or work with large numbers. Storage means storing in the computer, of course. When you have to store large number in the computer, there is a problem in using binary number. For example, we all know that in today's computers, it is not uncommon to have 2 GB of RAM or 500 GB of hard disk space. Now, the way data or instruction are stored in the RAM or in hard disk is that storage areas are broken down in sectors or bytes. Each sector has a physical address. This address is similar in nature to the street address that you have for your residence. Okay, you might have street address 16620, 1662125, and so on. But there is a small difference. Street address will never run into billions. Okay? But imagine that you have a gigabyte of RAM in your computer. That is 1 billion bytes. And RAM is addressable memory. Every sector of the RAM has to be given an address. Otherwise, computer cannot function to find data on the hard drive or in the RAM. And we're kind of going to talk about addressing of hard drive or RAM, because the addressing scheme is actually identical. There's not that much difference between the two. So if a sector of each sector is a 4 bytes, and each sector should have an address, then total number of sectors in 1 billion byte will be 1/4 billion, or 0.25 billion, or 250 million sectors. And if you compare that with the housing addresses, it will be as if house numbers run from 1 to 250 million. Okay? So let's say I want to represent these sectors in binary system. So I'm going to ask a question. What is 250 million in binary? It's actually this huge digit, huge string. So 250 million in the decimal was 1, 2, 3, and 3, and 3. 9 digits. All of a sudden, in the binary, that converts into 25 digits. And if you wanted to represent that in a string, large numbers in binary system gets too large, too many digits. Therefore, engineers designed another numbering system called hexadecimal, which has actually 16 digits. So binary has 2 digits, decimal has 10, hexadecimal has 16 digits. And what happens is that more digits you have in a numbering system, smaller is the number of digits you will need to use to represent a number on it. For example, in a minute we'll show you all the digits in hexadecimal, but let's say you want to represent 10. But 10 in decimal will be 2 digits, 1 and 0, but in hexadecimal is just 1 digit, A. So larger is the number of digits in a numbering system, smaller are the number of digits it's going to use to represent a number, especially true with the larger numbers, okay? So you can ask, how can a numbering system have 16 digits when actual digits are only 10, 0 to 9? So what happens is that we use 0 to 9 and then we use alphabets A, B, C, D, E, and F. So A will be 10, B will be 11, C will be 12, D will be 13, E will be 14, F will be 15. So 0 to 15 are the digits, 10 to 15 are A to F on the hexadecimal system. And we have a table here that shows hex digits. Hexadecimal is sometimes called hex, and their representation in binary system. So up to 0 to 9 is the same in both systems. Okay, difference comes when we have 10 to 15. 10 is A, 11 is B, 12 is C, D, 13 is D, 14 is E, 15 is F. So without much ado, now we will tell you what 250 million is in system based on hexadecimal. It's simply EE6B280. Already you can see what a huge reduction in number of digits has happened. Here it was 9, here is 1, 2, 3, 4, 5, 6, 7. We got a 2-digit reduction. If you go to even bigger digits, you will see the larger corresponding reduction. So it's incredible that how number of characters in the representation shrunk to mere 7 instead of 9 for decimal and 25 for binary. Therefore, hexadecimal numbers are very efficient in condensing the representation of large numbers. Okay, so in the video number 2, we will we'll have a procedure of how to convert hexadecimal to decimal numbers. And procedure, you can think of arrays are being used in C, but that procedure will be kind of independent of any data structure. All right. So this was the introduction to hexadecimal numbering system. In next one, I'm just going to show you a procedure how to convert hexadecimal to decimal numbers. Thank you.